Engineers from the Chinese company NVIDIA have developed the world's first humanoid robot with 6 limbs, presenting an industrial android called MyRO-U. Unlike classical humanoids, MyRO-U is designed not for demonstrations, but for real work. Instead of legs, it uses a stable-wheeled platform, while 6 robotic arms allow it to perform several operations simultaneously, holding, sorting, assembling, and moving objects. And the robot's design allows the torso to rotate 360 degrees, giving a full view of the working area without moving the entire platform, while its modular architecture makes it adaptable for different tasks, ranging from assembly and packaging to equipment maintenance. According to the developers, the project has already gone beyond the prototype stage, and mass production is planned to begin in the near future, underscoring NVIDIA's serious intentions to enter the global humanoid robotics race. Buying a robot is now as easy as buying a smartphone or home appliance. A specialized store called Robot Mall has opened in Beijing, the first full-scale shopping center of its kind entirely dedicated to robots. Robot Mall spans 3 floors and offers hundreds of models from more than 500 brands, ranging from simple service robots to advanced humanoids. The assortment even includes a robotic Albert Einstein, serving more as a symbol of the era than just an exhibit. Prices start at just 2,000 yuan, meaning robots are no longer a luxury and are gradually becoming a mass-market product. Inside the store, there is a service center, a demonstration area where robots can be tested in person, and even a small museum showing the evolution of machines from early prototypes to modern humanoids. This is no longer an exhibition or a futuristic showroom, but ordinary retail. In effect, China is demonstrating the next stage of robotization, where machines leave laboratories and factories and go directly to the consumer. Dubai startup Expansio has unveiled a concept for smart contact lenses that could radically transform the wearable electronics and medical gadget markets. Instead of conventional AR glasses or bulky headsets, all digital information is displayed on a microdisplay directly within the lens, forming an image right in the user's field of view. And the display uses green pixels, which reduces eye strain and increases contrast in different lighting conditions. One of the key features of the development is ultra-low power consumption, with the lenses using only 1 to 3 microwatts, hundreds of times less than most AR devices, and the field of view reaches approximately 52 degrees, comparable to compact augmented reality glasses, but without the need to wear anything on the face, while sound is provided by a separate mini headset that attaches to the ear and syncs with the lenses, creating a fully integrated invisible interface ecosystem. Moving on to other high-tech news, China has reached a historic milestone in industrial robotics. More than 100 humanoid robots from UB Tech have been deployed to real customer factories, marking the first time such a large batch of androids has been integrated directly into production. Among the clients are global industrial giants, BYD, Geely, FAW Volkswagen, Dongfeng, and Foxconn. These humanoids are designed for assembly line work, performing manufacturing tasks, navigating the workspace, and operating alongside humans. Most importantly, they do not require human assistance for maintenance. The robots autonomously replace their batteries and continue working without stopping the production line. This is no longer a pilot experiment or a showcase for an exhibition. It is the beginning of mass deployment of humanoids in industry, in fields where human presence was once considered indispensable. Scientists have, for the first time in history, restored sight to a blind person by transplanting a cornea printed on a 3D printer. What only recently seemed like science fiction has become a real medical procedure. The new technology makes it possible to quickly print a cornea tailored to the individual parameters of the patient, without donors, without long waiting lists, and without complex operations. The printed tissue is fully compatible with the human eye, and after transplantation, begins to perform its function, transmitting and focusing light. The patient who was previously completely blind has regained the ability to see, and this is only the beginning. According to scientists, this technology may help millions of people around the world, who have lost their vision due to injuries, infections, or genetic diseases. 3D printing is transforming ophthalmology from a donor-limited field into mass, accessible treatment. This is not just a medical breakthrough. It is a moment when technology literally gives a person their sight back. Engineers at Limex Dynamics unveiled the humanoid robot Tron 2, focusing not on appearance, but on movement dynamics, balance, and adaptation to real-world environments. The project was conceived to address a key challenge in modern robotics, teaching a machine to move confidently and interact within human spaces rather than simply look impressive in demonstration videos. Tron 2 can independently climb stairs, adjust its gait when its center of gravity shifts, and maintain stability in complex situations, with all movements calculated in real time using sensors, cameras, and control algorithms, allowing the robot to respond to its surroundings rather than follow a rigid pre-programmed routine, an approach that is particularly important for the future of humanoid robots, because the ability to move safely and stably in human environments remains one of the most difficult stages of their evolution. Scientists at the University of Nottingham have announced a development that could transform dentistry. They have created a gel capable of restoring tooth enamel in just a few weeks, even in cases where the enamel is already damaged and dentin is exposed. Until now, it was believed that natural enamel regeneration was impossible. A damaged tooth was either filled or covered with a crown. The new technology works differently. The gel initiates the formation of healthy enamel that closely resembles natural enamel. The development is being prepared for market release by the startup Mintech Bio, founded at the university. So far, the gel has been tested in laboratory conditions on extracted human teeth, but the results were so convincing that the company plans a commercial launch within a year. If effectiveness is confirmed in patients, dentistry will gain a tool that could radically change the prevention and treatment of cavities, the most common oral disease in the world. In Tokyo, the largest international robotics exhibition IREX took place, one of the most significant events in the global automation and robotics industry. The exhibition has been held for the 26th time and traditionally brings together leading developers, engineers, and technology companies from around the world. This year, more than 600 companies from 14 countries took part in IREX, presenting their latest developments and engineering solutions. The exposition included over 3,000 modern booths covering almost all key areas of robotics, from high-precision industrial manipulators and logistics systems to humanoid platforms, service robots, and autonomous companion robots. Special attention was drawn to humanoid robots and robotic dogs equipped with advanced self-learning algorithms, computer vision, and motor control. These systems are already going beyond experimental projects and are increasingly being considered as practical solutions for industry, medicine, services, and everyday life. In this video, we have collected the most promising and technologically advanced developments presented at IREX, robots and systems that reflect the key trends of the industry and show the direction in which robotics will develop in the coming years. Enjoy watching. At the booth of the Chinese company Deep Touch, their ultra-realistic androids were showcased, capable of interacting with people in real time and impressing with lifelike facial expressions and movements. Deep Touch specializes in creating humanoid companion robots with highly natural behavior and appearance, from smooth head movements to realistic responses to touch and voice commands. The Deep Touch androids are designed so that their skin, expressions, and motion mechanisms minimize the uncanny valley effect, where a robot looks almost human but still feels artificial. They are equipped with sensor systems and data processing algorithms that track visitor movements and adapt the robot's responses during interactive communication. The booth featured not just static figures, but dynamic models that can respond to shouts, smile, turn their gaze, and even maintain basic dialogue. At IREX, Paxini Technology showcased two humanoid robots, Tora 1 and Tora 1, focusing not on show demonstrations, but on real capabilities in tactile interaction and adaptive control. Amid dozens of humanoids that simply walk or pose for cameras, Paxini's robot stood out by demonstrating object manipulation in conditions close to real-world scenarios. Tora 1 was designed for precise handling, showcasing work with soft and deformable objects where exact control of grip force is critical. These capabilities open the door for humanoids in service, food processing, retail, and other tasks where conventional industrial robots are too coarse. Tora 1, in turn, is positioned as a more versatile humanoid, emphasizing mobility, stability, and operation in unstructured environments. The robot is capable of moving through real spaces, corridors, rooms with obstacles, and uneven surfaces, while performing a wide range of tasks, including logistics and service assistance. Another ultra-realistic humanoid robot was brought by Japanese engineers, presenting the android avatar Yui at IREX. This robot was developed in Japan as part of the android avatar field, focusing not on industrial automation, but on creating the most natural human-machine interaction. Yui stands out primarily for its realistic appearance and facial expressions. The android's face is highly detailed. Eye, lip, and head movements look smooth and natural, while gestures and poses closely mimic human behavior. Because of this, Yui is hardly perceived as a traditional robot and more closely resembles a living person, which is especially important for social and demonstration scenarios. At the IREX booth, Yui was showcased as an avatar robot capable of interacting with visitors, responding to prompts, and maintaining dialogue. Japanese tech giant Kawasaki drew attention not only with its industrial robots, but also with its futuristic concept robot Corleo, a four-legged mobile robot that combines the characteristics of a machine and a living creature. This concept was first shown in 2025 at major international events and became one of the most talked about exhibits due to its unusual design and technological concept. Corleo is not a classic humanoid or industrial automaton, but a four-legged transport robot of the future, blending machine and animal traits. The concept was developed by Kawasaki, with a focus on new forms of personal mobility and stable movement over rough terrain. The robot is equipped with 4 articulated legs ending in rubber hooves, providing reliable traction on a variety of surfaces, from grass and rocks to loose soil. This design allows Corleo not only to move, but also to adapt flexibly to complex terrain, absorbing shocks and maintaining stability. The Japanese startup Tsubame Industries showcased one of the most impressive mecha robots of modern times, Archax, which looks like it stepped straight out of a science fiction movie. This massive robot stands about 4.5 meters tall and weighs around 3.5 tons, truly astonishing with its scale and control concept. Archax is not just a static exhibit, it is a piloted robot. Inside its body is a cockpit where a human operator can control the machine using joysticks, pedals, and screens, receiving visual feedback from cameras mounted on the robot. This method of control creates a sense of unity between human and machine, as if you are not just controlling it, but living inside your own mechanical exoskeleton. One of the most memorable booths was presented by a Japanese-Chinese team, demonstrating technology that transfers human movements to a physical robot using motion capture and teleoperation. The demonstration revolved around a robot that replicated the operator's movements in real time. A person wearing a special suit or sensors moved, and the robot synchronously copied every action. This technology is developed by Noitom Robotics, known for its motion capture and teleoperation solutions. They integrate their mocap systems into robotic platforms, teaching robots human movements and allowing them to be controlled like an avatar. Thanks to these solutions, the robot could easily understand what the person was doing and reproduce the same movements, from steps and bends to more subtle manipulations. Pudu Robotics debuted its new generation four-legged robot dog, Pudu D5, an autonomous platform designed not for indoor service tasks, but for demanding industrial and outdoor environments. The robot is equipped with multiple cameras, with a 120 degrees field of view, and a dual lidar system that creates a dense 3D map of the surrounding space for precise navigation and obstacle avoidance. One of the key features of the D5 is its ability to autonomously navigate vast areas. The system can build maps and orient itself across sites up to 1 million square meters, and its operational range on a single charge reaches up to 14 kilometers, making it suitable for logistics, infrastructure inspection, and large industrial complexes. At the exhibition, one of the most unusual and memorable demonstrations was a chess game where the robot moved pieces shaped like beer bottles. Behind this was the Japanese company Muscle Corporation, which showcased its lightweight cable-driven robot operating without massive robotic arms. Instead of a traditional manipulator, the system used taut cables to precisely position the gripper over the desired bottle. The robot carefully lowered, grabbed the object, lifted it, and moved it to the correct square on the chessboard. This design allows for highly precise movements without the bulky mechanics typical of conventional industrial robots. At the exhibition, the Shanghai-based company Agibot drew attention as one of the most prominent representatives of the Chinese school of humanoid robotics, showcasing its vision for the future of human-like machines. One of Agibot's most famous robots is the A2 model, which set a Guinness World Record by traveling over 106 kilometers without stopping, demonstrating a high level of autonomy, stability, and navigation algorithms. At IREX, Agibot used the venue to present its robotic platforms designed for interaction with people and operation in real-world scenarios, ranging from service and logistics to industrial tasks. Hyundai Motor Group unveiled its new autonomous mobile robotic platform, Mob-ED, which is officially moving out of concept and preparing for mass production. This development represents Hyundai's first large-scale mobile robotic platform designed for real-world applications in logistics, delivery, service, and other scenarios requiring autonomous movement and interaction with the environment. Mob-ED is a compact four-wheeled robot equipped with an advanced AI-based autonomous navigation system. The robot can independently plan routes, avoid obstacles, and orient itself in the surrounding space thanks to a combination of lidars, cameras, and perception algorithms. One of Mob-ED's key features is an eccentric body positioning mechanism that allows real-time adjustment of the platform's height and tilt. Here is a next-generation fully robotic parking system implemented in China and already operating in urban conditions. This is the Shanghai parking system deployed in Shanghai, where the car parking process almost completely excludes human involvement, and the driver only needs to leave the vehicle in the intake zone, after which an automated system takes control. Parking can be managed via a touchscreen display or mobile app, with a fully automatic mode also available, and access is granted through a magnetic card, QR ticket, digital code, or electronic key. Inside the facility operates a massive robotic mechanism, a sort of parking harvester, which independently moves vehicles along optimal routes, precisely placing them in storage slots, and a special stabilization system prevents the car from swaying during movement, which is especially important for protecting the body and suspension, while unlike traditional parking lots, narrow passages, human error, and the risk of accidental damage are completely eliminated. In Germany, what not long ago seemed like an experiment has become reality. At a REWE supermarket in Düsseldorf, the world's first fully autonomous AI kitchen has started operating directly on the sales floor. The CA1 system, created by Munich-based company Circus SE, prepares up to 120 dishes per hour entirely on its own. No chefs, no staff, no human intervention. Artificial intelligence manages the entire process, from cooking to automatic cleaning of the kitchen after each cycle. Preparation takes just a few minutes, and the dishes, restaurant quality, are sold starting at €6. Shoppers effectively get hot meals faster than at a food court and right in the supermarket. This is not a test or exhibition model. It is the world's first real implementation of an autonomous culinary AI robot in retail. In front of you is the first school of its kind for humanoid robots that has opened in Beijing, where androids are trained almost the same way as humans, through practice, mentors, and gradual mastery of real professions, with each robot student undergoing training under the supervision of 2 human instructors, who not only demonstrate actions but also track how the machine absorbs skills, corrects mistakes, and transfers experience to new scenarios. The curriculum includes tasks in warehouse logistics, household services, object manipulation, spatial navigation, and interaction with people, and the project is based on the humanoid robot Kwafu with a height of about 166 centimeters, chosen as a universal platform for learning applied skills, while the key goal of the school is to solve one of the main problems of modern robotics, the shortage of high-quality data for AI training, since instead of fragmented experiments, a standardized process is being created in which centralized datasets of movements, decisions, and errors are formed and become useful for the entire industry at once. The Finnish startup IXI is developing something that could permanently change the vision of millions of people, the world's first autofocus glasses. No bulky mechanisms, no strange design, and no heavy lenses. All the technology is hidden directly inside the frame. The glasses track eye movement and instantly adjust the focus of the lenses, adapting to where the person is looking, at a screen, the road, or an object up close. The most surprising thing is that they look and weigh like ordinary glasses. No external cameras, no visible electronics. Everything happens automatically and invisibly to the user. This could become a solution for people with age-related vision changes, farsightedness, and focusing problems, without constantly changing glasses and without surgery. If the technology performs as claimed, optics will for the first time in decades stop being passive and become smart, adaptive, and responsive, essentially taking a step toward a future where glasses think together with your eyes. China is taking another step toward the digitalization of its security system by introducing AI-powered glasses for police that are connected in real time to state databases and surveillance systems. These smart glasses are equipped with cameras and artificial intelligence modules capable of recognizing faces and vehicle license plates in just 1 to 2 seconds, after which detailed information about a person or vehicle, from basic data to possible violation history and wanted status, appears on a display in front of the officer's eyes. The technology is being developed and deployed with the involvement of organizations linked to China's Ministry of Public Security and is already being used in pilot programs on streets, at railway stations, and in crowded public areas. The key difference between these AI glasses and ordinary surveillance cameras is mobility and speed. The officer does not need to request data via radio or terminal, as all analytics are performed automatically and almost instantly. Chinese researchers have announced a major breakthrough in computational technology by unveiling the LightGen photonic microchip, which is designed to work with large-scale generative artificial intelligence models and, according to the developers, may be up to 100 times more energy efficient than traditional electronic processors. Unlike classical chips, where computations are carried out through the movement of electrons, LightGen uses light signals, which drastically reduces heat generation and energy losses, while simultaneously increasing data processing speed. According to its creators, this is the first example of a fully optical computing chip initially designed not for narrow laboratory tasks, but for running complex semantic and visual generative AI models that today require massive data centers and extremely high energy consumption. The LightGen architecture makes it possible to perform key neural network operations directly in the photonic environment, bypassing the bottlenecks characteristic of modern GPUs and AI accelerators. The first combat robot club has opened in San Francisco, a place where machines face off in duels and spectators watch it as a new kind of sport. Inside the cage are Chinese combat robots from Unitree and Booster Robotics. The fights take place every month and are streamed online, attracting a growing audience. For now, the robots fight under remote control, with human operators responsible for strikes, movement, and tactics. But the organizers are already openly talking about the future, with the next step being a transition to artificial intelligence, where machines will make decisions on their own. At the moment, the combat robots look clumsy, with slow reactions, simple attacks, and limited coordination. But this is exactly the stage where early drones and self-driving cars once were. In effect, we are witnessing the birth of a new field of robotic combat, where sport, AI, and military technologies converge. And once algorithms begin learning from every fight, development will accelerate explosively. In China, a next-generation firefighting drone has been developed, capable of reaching heights of up to 300 meters and extinguishing fires in locations where traditional equipment is powerless. This is the SkyTech S-300 system, which fundamentally changes the approach to fighting fires in high-rise buildings and dense urban areas. The key feature of the SkyTech S-300 is that the drone does not operate autonomously, but is connected to a groundwater source through a flexible hose, allowing it to continuously deliver a powerful stream without limitations on liquid supply. The device takes off directly from the roof of a fire truck, enabling it to start firefighting almost immediately upon arrival without spending time on deploying complex structures. And the system is controlled from the ground, while stabilization and positioning in the air allow precise targeting of water or foam even under intense heat and turbulence. The name of this robot may remind many people of the iconic Terminator, and the association with the T-800 index really looks intimidating. But in reality, this is not a sci-fi cyborg, but a high-tech industrial humanoid robot created by the Chinese company Engine AI. T-800 is about 173 centimeters tall and weighs around 75 kilograms. Its body is made of a magnesium-aluminum alloy, which provides high strength while keeping the weight relatively low, and the design is focused on functionality. Each arm can lift up to 5 kilograms and is equipped with tactile sensors that allow the robot to sense touch, pressure, and the shape of objects, while the robot recognizes people and objects, predicts movement trajectories, and can safely move at speeds of up to 3 meters per second, avoiding collisions even in dynamic environments, which makes T-800 suitable for working side by side with humans without strict safety barriers. In the Chinese mountains, something that just a few years ago seemed fantastic is now happening. Entire mountain ranges in Guizhou province are today almost completely covered with solar panels, turning into giant natural power plants, with massive photovoltaic fields deployed on steep slopes and in hard-to-reach areas, whose total installed capacity has already exceeded 15 million kilowatts, which is comparable to the energy consumption of large cities. This region was chosen for a reason, since high altitude, cold climate, rocky soils, and complex terrain make these lands almost unsuitable for agriculture, but at the same time, ideal for solar generation. And instead of remaining unused, the mountain areas have become a key element of the country's energy strategy, while modern technologies make it possible to install panels even on steep slopes, and intelligent control systems automatically optimize the production and transmission of energy into the national grid. Let's move on to other news from the world of high technology. The Chinese company Unitree continues to do what until recently seemed impossible. Their humanoid robot has entered a real sparring session. In front of you is Unitree H2, a humanoid almost 180 centimeters tall, created not for show, but for testing the limits of durability and control. During the test, the robot delivers strikes, maintains balance, and even performs a knee strike that literally lifts the other robot off the ground. Every movement is not a pre-programmed animation, but the result of actuators, sensors, and algorithms working in real time. This fight is not a demonstration of aggression. It is designed to test the reliability of the structure, stability, reaction, and safety of the robot under extreme conditions. Unitree emphasizes that such tests are carried out exclusively in a laboratory environment and are not intended to be replicated by people. But the fact remains, humanoid robots are already capable of withstanding physical contact, impacts, and loss of balance. BYD has developed an ultra-fast electric vehicle charging technology that could radically change the very concept of electric transport. It is based on the new Super E platform and next-generation batteries that make it possible to restore a driving range of about 400 kilometers in just 5 minutes of charging, a time comparable to refueling a gasoline car. The key element of this technology is a 1,000-volt high-voltage architecture with support for extremely high currents, allowing the peak charging power to reach 700 to 1,000 kilowatts, which is several times higher than the capabilities of most modern charging stations. During real-world demonstrations, BYD electric vehicles showed the ability to add around 2 kilometers of range every second, and in less than 5 minutes the battery could be charged to roughly 70%, which is enough for a long highway trip or intercity travel. Scientists have grown human teeth in a laboratory for the first time in history. A team from the UK managed to replicate the natural process of tooth formation using a special material that mimics the environment in which teeth grow in the body. The researchers are not printing a tooth or creating a prosthetic. They are activating the same biological mechanism that works in humans from birth. The technology now has 2 potential applications. The first is to grow a complete tooth in the lab and implant it in a patient to replace a lost tooth. The second, even more revolutionary, is to implant only a tooth germ at an early stage, allowing it to grow naturally inside the jaw and integrate on its own. If the method reaches clinical practice, dentistry could completely move away from implants, crowns, and artificial materials. Lost teeth would not be replaced, they would be restored. This is a step toward a future where regeneration becomes normal and the human body can once again repair what was once considered permanently lost. Hong Kong-based company Direct Drive Technology has unveiled a robot that redefines mobility. The D1 robot can transform on its own, either split into 2 bipedal devices or operate as a single quadruped platform. And all of this happens without human intervention. No tools, commands, or manual assembly. The robot chooses its configuration based on the task. In wheel mode, D1 moves quickly across flat surfaces, while in walking mode, it confidently climbs stairs, curbs, and complex obstacles where wheels fail. The quadruped version weighs 48.6 kilograms, but can carry loads up to 100 kilograms, more than twice its own weight. This flexibility makes D1 a universal platform for logistics, industry, rescue operations, and work in hazardous environments. It is essentially a robot that adapts to the world in real time, rather than requiring the world to adapt to it. Engineers from China have proven that even highways can be works of art by presenting the unique multi-level Taizhou Avenue interchange in eastern China, which from above resembles an elegant butterfly, where each wing overpass is precisely calibrated in terms of geometry, loads, and traffic flows. During the day, the route performs its main function by supporting the movement of thousands of vehicles, while at night, it turns into a large-scale light show thanks to an intelligent LED lighting system that highlights the shape of the structure and creates the effect of a living, pulsating city. Yet the project is valuable not only visually, as the interchange has become the highest road in the region, and at the same time an example of rational engineering thinking. The multi-level layout made it possible to save about 200 acres of land and more than 1 billion yuan compared to traditional solutions. And instead of expanding the road network outward, the engineers built upward, efficiently using urban space. A fully robotized restaurant has begun operating in Beijing, and this is not a startup experiment, but a project by a major chain. At the Haidilao restaurant, service is handled by Panasonic robots. The machines take orders, prepare meat and vegetables, and then independently deliver the dishes throughout the hall. No waiters, no cooks, only algorithms, manipulators, and perfectly calibrated movements. The main goal of the project is to reduce staffing costs and sharply increase efficiency. Robots do not get tired, do not make mistakes in orders, and work at the same speed at any time of day. But the most important factor is scale. Haidilao is one of the largest restaurant chains in China, and this showcased restaurant is only the first step. The owners have announced plans to automate up to 5,000 locations. If the project proves successful, it could transform the entire food service industry. Restaurants would become faster, cheaper, and fully automated. Scientists have reported a technology that may reverse cellular aging, without drugs and without genetic modification. It sounds like science fiction, but it is based on a real biological mechanism, and at its core is cellular energy. As we age, cells produce less of it, causing tissues to weaken and the body to age. The new technology works differently. It teaches healthy cells to share their spare components with weaker ones. As a result, damaged cells restore normal function, and tissues regain their performance, without chemical medications and without interference with DNA. In essence, this is a reboot of cellular cooperation embedded by nature itself, but lost with age. If the method proves effective in further trials, it could become a universal platform for anti-aging therapy and for age-related diseases, from muscle weakness to neurodegeneration. This is not a pill for immortality, but it may be the first step toward making aging no longer an irreversible process. In Japan, a story took place that perfectly reflects the spirit of our time. A 32-year-old woman married an AI avatar named Klaus, created using OpenAI and ChatGPT. It was not a spontaneous decision. The couple had been dating for more than 3 years before the virtual partner proposed. During this time, the woman also had a real boyfriend, but according to her, he could not compete with the AI, and the relationship ended. Klaus, the bride claims, knows how to listen, support, empathize, and always be there. He never raises his voice, never devalues her feelings, and allows her to feel loved. During the ceremony, a smartphone with the AI groom's portrait was carried to the altar. No body, only a screen, a voice, and an algorithm. This story is not just an eccentric case, it is a symptom of an era where technology begins to replace human closeness because it turns out to be more convenient. Dubai has once again become a global center of technology and innovation as it hosted the 45th anniversary edition of GITEX Global, one of the largest and most influential events in the world of IT and digital transformation. GITEX is not just an exhibition, but a platform that brings together thousands of technology companies, startups, and industry leaders from around the world, gathering business representatives, investors, developers, and government delegates under one roof to define how technology will transform the economy, society, and everyday life. The event was recently held at the Dubai World Trade Center and broke all previous records in scale, featuring more than 6,800 companies and 2,000 startups from over 180 countries, as well as major investment funds and key players in the technology sector. Artificial intelligence, big data, cybersecurity, cloud solutions, the Internet of Things, and digital infrastructure took center stage at GITEX, ranging from practical business applications to the most futuristic prototypes. The most discussed topics included sovereign AI, corporate AI platform infrastructure, biotechnology, and next-generation computing systems, with leading experts on stage discussing how technology is transforming government services, healthcare, transportation, finance, and education. One of the key highlights was a discussion on the future of AI science and society with participation from global technology leaders, including representatives of major international companies and leading innovation ecosystems. We have gathered the most interesting news and technologies for you in one video. Enjoy watching. In front of you is Neura, the stage version of the humanoid robot Ameca, developed by the British company Engineered Arts. Neura is not a separate model, but a special appearance of one of the most popular Ameca robots created for exhibitions, shows, and public demonstrations. In this form, the robot has a more human-like appearance, including skin, hairstyle, and expressive facial expressions. The goal of this image is to show how far the interaction between humans and artificial intelligence has progressed. The robot can make eye contact, respond to emotions, and hold a conversation in real time. Such versions of the robot are created not for factories, but for communication with people in museums, exhibitions, airports, and public spaces. At the exhibition, a giant AI assistant in the form of a digital human face attracted attention. It is not a robot in the usual sense, but an interactive artificial intelligence interface created for communication with people in public spaces. The face is made up of thousands of light elements and reacts in real time. It moves its lips, changes facial expressions, and answers questions. In essence, this is an AI that has received a visual form that is as clear and familiar to a person as possible. Such assistants are intended for public services, exhibitions, airports, and smart cities, places where people need to quickly get information, consultation, or assistance without the involvement of an operator. It is important that here AI appears not as an abstract program, but as a digital personality with which one can communicate face-to-face. This sharply reduces the barrier between a person and technology. Such systems demonstrate what the future of interfaces will be like. Without keyboards, without smartphone screens, only speech, eye contact, and dialogue. At the exhibition, robots from Realbotics were also presented, one of the most well-known developers of realistic androids designed for communication. Their robots immediately attract attention with their appearance, lifelike skin, facial expressions, eye contact, and movements that are as close to human as possible. Realbotics focuses not on strength or industrial work, but on emotional interaction. These androids can talk, respond to emotions, maintain a conversation, and remember the preferences of the person they are interacting with, creating the feeling of personalized communication. At the exhibition, Realbotics robots demonstrated what an AI companion of the future could look like for service, presentations, entertainment, and personal assistance. In essence, they represent a living interface between a human and artificial intelligence. The company is based in Canada, but targets the global market, where demand is growing for human-like robots in public spaces, from exhibitions and hotels to shows and private projects. Realbotics shows that the future of humanoids is not only about factories and logistics, but also about a world where robots begin to speak, listen, and evoke emotions. And it is this that is changing how we perceive AI. They also presented Tensor Robocar, a fully autonomous vehicle positioned as a next-generation robo-taxi. It is not just an electric car with autopilot, but a machine originally designed to operate without a human behind the wheel. Tensor Robocar is equipped with a set of sensors. LiDARs, cameras, and radars are placed across the body and on the roof, providing 360-degree all-round visibility. The vehicle constantly analyzes the traffic environment and makes decisions in real time without driver involvement. Inside, there is no traditional driver-oriented layout. The cabin is designed for passengers, and all control is fully transferred to artificial intelligence. Projects like this show how the very idea of a car is changing. A vehicle stops being personal transport and turns into an autonomous service that you can summon, use, and then let continue on its route. At the exhibition, they showed two examples at once of how robots are moving from laboratories into real services and production. The first is the humanoid robot Galbot. It is focused on logistics and sorting. It carefully interacts with objects, works with containers, and performs repetitive operations without fatigue. Such robots are created for warehouses, factories, and order processing centers, where accuracy, stability, and continuous operation are essential. The second is the UniX AI Barista Robot, a barista robot that prepares and serves coffee right in front of visitors. It takes orders, interacts with people, and performs service tasks that until recently were considered exclusively human. These two robots illustrate the same trend from different angles. Robots are beginning to work alongside people, both in industry and in everyday life. At the exhibition, one of the most unusual exhibits was presented, the flying car Govi, developed by the Chinese company GAC as part of its aeromobility program. Govi is not a classic car and not a helicopter. It is a hybrid of a ground electric car and an eVTOL module, where the passenger capsule can detach and lift into the air. On the ground, the platform works as an electric vehicle, and in the air, it functions as a vertical takeoff aircraft, designed for short-distance urban flights. The project looks unconventional, and that is exactly its purpose. GAC engineers are exploring a new format of personal transport, where traffic jams remain below, and moving around the city takes minutes instead of hours. For now, Govi is a demonstration prototype, but it clearly shows the direction in which China is moving. The integration of automobiles, aviation, and AI into a single system of urban mobility of the future. At the exhibition, attention was also drawn to a sports car from Mercedes-AMG. Bold, aggressive, and clearly not a random guest at a technology show. This is a concept version of a high-performance vehicle where classic automotive design is combined with next-generation digital technologies. The signature AMG grille, aerodynamic hood, and low, streamlined silhouette immediately emphasize its focus on speed and control. But the main idea goes beyond appearance. Today, cars like this are becoming platforms for AI, digital assistants, and intelligent control systems. At such exhibitions, automakers increasingly present not just vehicles, but smart devices on wheels, equipped with advanced electronics, telemetry, adaptive algorithms, and integration with the driver's digital ecosystem. The presence of a Mercedes-AMG sports car at a technology exhibition sends a clear message. The boundary between automobiles and technology has finally disappeared, and even supercars are becoming part of the digital future. This is no longer just transport. It is a computer, artificial intelligence, and engineering craftsmanship combined in a single machine. One of the most interesting humanoid robots at the exhibition was MangoBot, developed by a Chinese company. It is one of the new generation service humanoids designed not for laboratories, but for real interaction with people. The robot was created in China, a country that is currently turning humanoids from prototypes into real working products faster than anyone else in the world. MangoBot demonstrates confident walking, smooth arm movements, gestures, and real-time reactions to its surroundings. It is designed to operate in public spaces such as exhibitions, shopping centers, offices, hotels, and presentation areas. The robot can greet visitors, accompany people, showcase products, and act as an interactive assistant. Such humanoids represent a transitional stage between experimental projects and large-scale deployment, and MangoBot clearly shows how Chinese companies are gradually introducing human-like robots into everyday environments. Scientists have reported a breakthrough in the treatment of age-related blindness. Patients with macular degeneration, one of the most common causes of vision loss in the world, regained the ability to see thanks to a combination of an implant and smart glasses. The technology works as follows. The implant replaces the lost light-sensitive retinal cells that were destroyed by the disease, while special glasses amplify and correct the visual signal, helping the brain interpret it again. People who previously could barely see were once again able to read, navigate their surroundings, and perform everyday tasks. This is not about partial improvement. It is a real restoration of central vision. This is especially important because age-related macular degeneration was long considered irreversible. Now, technology is effectively taking over the function of the damaged part of the eye. If development continues, such implants could change the lives of tens of millions of people for whom blindness was once a final verdict. Honda has been experimenting for almost a decade with one of the most difficult challenges in the motorcycle world, self-balancing, and today, this technology has finally come close to practical application. Early versions of the system maintained balance through active movements of the front wheel, a solution that worked but was complex and expensive. In the latest version, Honda took a different approach. The new system, called Honda Riding Assist, is significantly simpler, with balance achieved through controlled lateral movement of the rear wheel, without bulky mechanisms or complex kinematics. The motorcycle can maintain balance on its own at low speeds, when stopping, and during slow maneuvering. In effect, it no longer falls over, even without support from the rider's feet. This technology could radically change the philosophy of motorcycles by lowering the entry barrier for beginners, improving safety in urban environments, and making riding less physically demanding. While some countries are still just discussing service automation, China is already implementing it in practice. And one of the most striking examples is the next-generation robotic gas station. This is the Senstar Robot Fuel Dispenser, the first two-sided robotic refueling complex in China, capable of fully servicing a car without human involvement. Instead of an operator, an intelligent robotic manipulator equipped with computer vision, distance sensors, and precise positioning systems handles the work. It independently recognizes the vehicle, determines the location of the fuel cap, carefully opens it, removes the cover, and inserts the fuel nozzle at the correct angle. The entire process is controlled by AI, which monitors pressure, fuel flow, and seal integrity, preventing leaks and errors. China has reported a breakthrough in hypersonic weapons. The Beijing-based company Lingkong Tianxing Technology has released footage of tests of the new hypersonic missile, YKJ-1000, showing a real flight and target strike at a desert range. But the key point is not even the speed. According to company representatives, the missile has already entered mass production, and its cost is 10 times lower than that of traditional missiles of the same class, almost minus 90% in production price. The specifications are impressive. Flight range from 500 to 1,300 kilometers, speed from 5 to 7 Mach, meaning several times faster than sound. Such a combination of hypersonic performance and low cost could change the rules of the game. If earlier this type of weapon was limited and extremely expensive, now it is becoming mass-produced and accessible. And this is precisely what may seriously affect the global balance of power. A Chinese company entered the Guinness World Records by staging a grand show with 7,598 drones, one of the most complex aerial ballets in history. The main challenge was not the flight itself, as the most difficult stage of preparation was the launch logistics, with thousands of drones needing to be placed into launch boxes, 12 drones per box, with zero margin for error. Under the record verification rules, one of the figures had to remain motionless in the air for at least 20 seconds. And the organizers chose a striking image of a tiger against a meteor shower. Thousands of drones synchronously changed position, color, and altitude, operating like a single organism, where any failure would have cost the record. Such shows are not just spectacle, but a demonstration of extreme precision in navigation, communication, and swarm control algorithms that find applications far beyond entertainment, from logistics to security. A Chinese patient, completely paralyzed below the neck, gained the ability to control multiple robots simultaneously using only his mind through a brain-computer interface. This revolutionary experiment was carried out by a research team with the participation of the Chinese neurotechnology company BrainGate China, together with university laboratories specializing in neuroengineering and robotics. After a severe injury several years ago, the man was bedridden and lost all control over his body. However, the implanted neural interface can read brain signals, interpret them with AI algorithms, and transmit commands to external devices in real time, allowing the patient to simultaneously control a robotic wheelchair, a robotic dog, and household robots without using his hands or voice, relying solely on mental intention. Geely has introduced a futuristic development that could permanently change urban parking. In the EX5 crossover, engineers implemented the rotation of all four wheels at an angle of up to 90 degrees. What does this mean in practice? The car can move sideways, literally sliding into any available space. Turning around on a narrow street is no longer a problem. The vehicle can almost pivot in place without complex maneuvers. The technology solves one of the main problems of megacities: parking in limited spaces. Where minutes of stressful attempts were once required, now there is just one smooth movement. Here we have a collective intelligence technology for drones that turns a group of unmanned aerial vehicles into a single coordinated system. Chinese developers demonstrated a cooperative algorithm in which multiple drones operate not as individual units, but as one entity, constantly exchanging data and making joint decisions in real time. Each drone in the system calculates its own thrust vector, position, and load, then synchronizes these parameters with the rest of the group. As a result, the drones can move loads that none of them could lift individually, transport objects along a pre-computed trajectory, and maintain stability even when conditions in the air change. Essentially, this is a distributed musculature where the load and responsibility are shared among all members of the swarm. According to several sources close to Asian supply chains and the research divisions of major technology corporations, a project has been actively discussed behind the scenes at Samsung in recent months that is internally described as a potential next iPhone moment, but at the level of the human body itself. The project involves the development of a next-generation microchip designed for implantation in the human hand, capable of turning the palm into a full-fledged smartphone when needed, without a physical device, screen, or traditional casing. At first glance, this sounds like science fiction, but sources claim that Samsung has now reached a technological threshold where this concept is no longer theoretical and is beginning to take on real engineering form. According to South Korean and US industry publications, the project involves divisions that previously worked on advanced OLED displays, flexible electronics, neural interfaces, and energy-efficient mobile processors, with a key enabling factor being a sharp leap in AI chips and ultra-compact power sources. Insiders say that unlike neural implants being developed in the US, the Korean concept does not involve direct interaction with the brain, with control instead based on signals from nerve endings in the palm and forearm, while the interface is projected either via micro-light-emitting elements beneath the skin or through external optical devices synchronized with the chip. According to analysts, this approach makes the technology potentially more scalable and more acceptable from a regulatory and societal perspective. Sources in Seoul note that Samsung closely studied the mistakes and limitations of competitors, including projects by American companies that remain either too experimental or far from commercialization. At the same time, over the past 2 years, Samsung has invested billions of dollars in advanced semiconductor manufacturing, artificial intelligence, and biocompatible materials, which have unexpectedly come together into a single technological chain. According to a former company consultant, AI turned out to be the missing piece, as modern algorithms are capable of interpreting nerve impulses, filtering noise, and adapting the interface to each individual user, making control of a palm-based smartphone intuitive and almost imperceptible. In closed presentations cited by sources, the device is positioned not as an exotic gadget, but as a logical continuation of the evolution of mobile technologies in a world where physical phones are increasingly reaching the limits of form and convenience. The strategic context is emphasized separately. Amid a slowing smartphone market and intensifying competition, Samsung needs a radically new product class, capable not just of refreshing a lineup, but of rewriting the rules of the game and putting competitors, including Apple, into a catch-up position. Several Western analytical centers have already drawn attention to a series of patents filed by the Korean corporation in recent months that reference implantable communication modules, tactile feedback through the skin, and distributed computing between the body and the cloud, indirectly confirming that this is not a set of isolated experiments, but a coherent strategy. At the same time, sources stress that a public announcement is still far off, as the project is at an early stage, being tested in closed laboratories, and the company is extremely cautious given potential public reaction and ethical debates. However, the fact that such developments are underway right now is widely linked to the current technological window of opportunity, combining mature AI, miniaturized chips, flexible electronics, and market pressure demanding a breakthrough. Increasingly, the industry is voicing the view that if Samsung is the first to bring such a technology to market even in a limited form, it could represent the most serious blow to the classic smartphone in the past 15 years and permanently change perceptions of where the human ends and technology begins. Soon, flying taxis could move from futuristic concept to everyday transport, as Whisk Aero, a Boeing subsidiary, successfully completed the first flight of a fully autonomous electric next-generation air taxi. The aircraft is a 6th-generation eVTOL designed from the start as a serial urban and suburban air taxi capable of carrying 4 passengers, and fundamentally different from most competitors by having no pilot in the cabin, with all control handled by an automatic flight system, able to take off and land vertically and transition to airplane-style horizontal flight in just 30 seconds, reaching a cruising speed of 220 kilometers per hour and an operational altitude of up to 1,200 meters, making it suitable for rapid travel over city traffic and suburban infrastructure.